As you see, our modern life is unthinkable without highly advanced equipments we use here on Earth or even in space. And as we discussed, one of the most potent R&D direction is the exploration of the possible applications of quantum mechanics and their transfer to engineering practice. And I think the core signs are the digitalization, the IoT, the big data, the artificial intelligence, machine learning and deep learning. So I think behind these core signs are many interesting things, and now we will concentrating on the electronics industry. How is this in the electronics industry? Is the question is that is the digital transformation still taking place in our industry? Is it possible to increase the production efficiency by for example, by communicating machines? And is there a way to much better use of data generated at manufacturing sites, at each manufacturing site? And are there any initiatives to form data-driven manufacturing, and etc., etc.? There are many questions, and I'm sure there are answers this afternoon. And our kind guest who is here today is Matt Kelly, who will give us these answers. And now I ask you, Matt, can you hear me? Are you here with us?
Yes, I can hear you. Can you hear me okay?
Okay. Yes, it's good. Thank you. Welcome to our conference, online conference. And just about you in a nutshell, Matt is a chief technologist at IPC, the Global Association for Electronics Manufacturing. He comes to IPC following probably 30-year career at IBM, and he helps the industrial players to engage the latest technology advancements and digital transformation. So I think his work is very interesting, and now I kindly ask you, please share us your thoughts concerning this issue. Thank you.
Okay, great. Thank you for the introduction. Thank you all for your time as well, and most importantly, thank you for speaking English. Greetings from I'm based in Toronto, Canada. Here we've been very focused at IPC over the last couple of years now on the application of many technologies, which I'll share with you today. And the goal is to really make sure that we're implementing these within the shop floor and within factories worldwide. So today I'll be speaking to you about enabling the factory of the future through one of the newer protocols, IPC Connected Factory Exchange, that we've developed. If you'd like to get in contact with me, there's my email and LinkedIn address. So today, roughly just 20-25 minutes worth, we'll be touching just briefly on the Factory of the Future initiative that we have, putting it into an electronics manufacturing industry context with definitions, expectations, talking about integration levels, as well as ROI delivery focus. And then in that context, we'll move into some more specific with Connected Factory Exchange and what that can do for us. So I'm sure many of you have seen this magazine cover. It's quite popular now. Published first in May of 2017, and calling for data as the new world's most valuable resource. So if we take a look at, what data is a very interesting thing. I equate data to electricity in some cases. Electricity sometimes, or chemistry, is difficult to understand because you can't see it all the time. I would argue the same thing with data. So we've got lots of data quantities flying around. Here's one that's very recent, within the last quarter here. So it's estimated that there's something in the order of 2,200 terabytes of data that can be generated in a single manufacturing site in just 1 month alone. We know that there's only about 10 or 20% of that's being utilized today. So, what does that number look like? So, how big is 2,200 terabytes? And so just a very simple calculation. We would never be doing this in practice, but again, it just gets our mind around the size of the problem that we're talking about. So, a terabyte is 1,000 gigabytes, and on your laptop today, you're somewhere between 500 and 2 terabytes capacity. So if you are to look at this in a scaled version, just do the math. You're basically looking at, somewhere between 500,000 and 1.5 million laptops worth of data a year that keeps coming, that doesn't stop, that you need to be making sense of each and every single day. So again, we know we wouldn't be purchasing this many laptops, but it gets your mind into a size of what we're dealing with. Okay, so let's first talk about our Factory of the Future initiative here at IPC. So to set the stage, let's talk about integration levels. So if we look for the past 5, maybe 8, 10 years maximum, up until roughly today, this is what's really been happening. So when companies have been investigating and investing in their Industry 4.0 journey, they're really working at it in an individual company or factory level. This is not a bad thing. This is a great thing. Lots of really interesting innovations are occurring. It's solving problems like productivity, efficiency, and obviously needing return on investment for those applications that have been installed. And so it's a certain set of problems that are being addressed. Now, we all know that the electronics industry doesn't work like that. It's actually a collection of obviously many different companies in the supply chain. And I've shown that here in this second phase, where OEMs typically dominate the requests, because that's where the product is born, and they're working with EMS, PCB supplier, components, mechanicals. I've simplified it here, but really it's an OEM defined ecosystem that is producing a product, and you're solving a different set of problems here: faster cycle times, worrying about quality, reliability, and most importantly, data-driven supplier management. We take it one step further, and I would argue that not many are thinking about this or addressing this in a practical sense at this point, where we know the industry as a whole is actually a collection of different EMS providers, PCB suppliers, et cetera, gaining economies of scale. A single OEM would be serviced by multiple different ecosystems running at the same time. So here we have big company, small company, different market segments, regional and global supply chains. And so this industry-wide view of transformation is something that is still very much in its infancy. We're still back in, I think, box number 1, maybe box number 2. But at IPC, this is what we're really focused on, because what I'd argue on this slide is it's like a reversible reaction. In chemistry, some reactions are reversible, some are not. And if we make decisions today that might not be optimal, then it could impact our performance in a very few short years here. So we're really trying to take a look at this modernized infrastructure from an industry-wide transformation perspective. So we've heard Industry 4.0 for many years, smart factory, smart manufacturing, lots of different ways to describe this. We call it factory of the future. As an engineer myself, this is just a description. What does it really mean? It means modernization, and it means that continual drive for advancement. It's very important why we selected this particular name, Factory of the Future, because for us, this is not just about digitization with monitors and dashboards and making it look more modern. What it is actually delivering modernization. And on top of that list are very highly skilled people. We're seeing new roles, new skills that are not even being called for right now. Things like chief digital officers, chief AI engineers on floors. These are new skills and requests that will be needed going forward. New technologies, of course, conventional technologies. Look, we still build printed circuit boards and printed circuit boards assembly roughly in the same way. They're getting smaller, they're getting faster, they're getting more powerful, but the same basic flow applies. And my favorite, what I call good old-fashioned engineering, there's a lot of really good tools and processes out there, quality management systems, statistical process control, supply chain management. These have been around for a very long time, but I would argue are practiced well in some cases and not practiced so well in other cases. So this F2 notion, Factory of the Future, is really a combination of some new things as well as heightened awareness on good tools available today. We need to make sure we have an end-to-end view of this. So this obviously starts with design, goes all the way through the MPI cycle into final system build. We need to be patient with this. I think that the idea of this being a revolution is quite difficult for all of us that have been in the industry for a long time. We know these things work more in an evolutionary perspective. So we'll be making significant advancements over the next 2 to 3 years, especially with the digitization and remoteness of these unfortunate COVID period that we have right now. But we do need to be patient because there will be a long run to this as well. Main reason for this is capital expenditure and skills required. So here's a brief overview of the program. I don't want to spend as much time on this. If you do have questions or comments or would like to get more involved with it, please feel free to contact me. Really, the vision is to harness the full potential of Factory of the Future, but really focus on delivering measured business value. Right now, we're in stages of promoting and accelerating this modernization. We've kicked the program off as of November 2020, this past fall. It's structured to foster industry-wide awareness, collaboration, adoption, getting the expertise together that needs to work together to solve this, as I showed in the other slide. Individual companies or ecosystems will be successful, but we need to think about the larger play as well if we're really going to have an end-to-end supply chain working with these types of concepts. I mentioned we're implementation focused. I'll talk a little bit more about that. And we're trying unified, standardized, and simplified solutions. We've got a variety of different offerings in terms of how to get us from where we are today over the next few years. So we're very closely working with a variety of industry work groups as the new technologies develop. I lead a chief technologist council where we're getting the brain trust of many different OEMs and EMS PCB suppliers, really focusing on real world problems, what needs to be solved. CFX, I'll talk about growing our digital standards portfolio. When many people think about IPC, and I think it comes from the heritage of IPC, it's about solder joints and the physical aspects of hardware. Because of the things that are changing in the operations, we're also adding to that a whole variety of new digital standards, things like cybersecurity, digital twin, CFX, which we'll talk about, AI-based type of inspection systems, etc. So let's talk about the current state of modernization. So from a geo perspective, Europe has been leading and always been leading. We can go back even early 2000s, the birthplace, I guess, of Industry 4.0 in Germany. Asia Pacific is definitely gaining momentum. That's simply because of the scale and the amount of product that's being built there still today. North American geographies, including South America, are somewhere between 5, 8, and maybe even 10 years behind the curve. From a segment perspective, silicon fabrication and packaging, they've always been leading, arguably 10 to maybe even 15 years ahead of hardware assembly. That's because they need to, dealing in the small scales, the nanometer node dimensions that are coming out, just to get yield and quality, that they need to have that level of control. Adoption is very, very low. Right now, we see at best 20% adoption throughout the industry, with very high failure rates reported for early programs. The good news is that transformation is occurring, but as I mentioned, it's moderate and slow still at this period. And the graphic I'm showing you here at the bottom is really, I think, where the industry is right now. I think, as we turn on our computers each and every day, there's no shortage of information. So the awareness of what we can do, what we want to do, what we need to do is very high. Unfortunately, the implementation of that and how to get that into facilities, get that into supply chain, get that into your new product introduction cycles is very low. So focusing in on implementing, converting those tools and those opportunities into real actionable items is where the value is. In terms of technology stack, if you look left side, right side of this chart, if we look over the last 20 years, this is just a very short list of things. I'll use lead-free electronics as kind of the example here. We're already at 20 years of researching and understanding lead-free converted electronics. Much of what is shown here is very important. It's reliability-based, quality-based, but in many cases, it's also considered mature. Excuse me. So looking forward, we are absolutely looking at those conventional hardware technologies, but we're focused in on the advancements. A really good example is miniaturization, PCB, high density interconnects, microvias, new quality and reliability issues for 5G, high speed millimeter wave networks, those kinds of things. Lots of really interesting stuff going on there. This is what's needed for the future. But building upon that conventional hardware technology, you can see in the upper right-hand corner is this grouping of emerging and disruptive technologies, and we know that list very well. So essentially, we're building upon the core of what's been done for the last 20 years to a couple decades or so, but we're now expanding into these new digital areas. So let's take a look at ROI. I mentioned that earlier, again, just with my previous experience in an OEM, science projects and interesting things to work on. There's absolutely no room for that in today's world. Whatever you're developing or providing as a solution needs to be implemented for return on investment, either to the facility, to the operation, or to the product itself. On the right-hand side, you can see there's a collection here of approximately 25 different future disruptive technologies that we maintain and track and develop here. And this is the list that we've seen every day. I think, unfortunately, just with the excitement behind these technologies, there's a lot of really interesting things. Each one of these is its own expertise area. And again, from a technology perspective, just lots and lots going on all at the same time. But I think what, unfortunately, the industry is forgetting a little bit, just because of the industry excitement around the technology itself, is that we need to stay focused on number one is solving the business challenge. And so what we see is, we talked about that low adoption, those high failure rates being reported. It's because they're taking the tool in the toolbox, the technology, and they may or may not be using it correctly. So this slide is really to make sure that we're reminding industrial solutions to be business challenge focused, and then apply the proper tool or the proper skill or the proper approach to solve that problem. It sounds obvious when I say it, yet when we talk amongst all leaders a wide variety of leaders in the industry, this often gets diluted, in this excitement of technology. So that's all I really wanted to cover regarding Factory of the Future. If you have any more interest in this area, you can see the website at the bottom. You can contact me. We are absolutely future focused here, and really trying to get the industry moving in this area. So with that context, let's move into something more specific, connected factory exchange. And so, this is absolutely fundamental to enable Factory of the Future and data analytics. On that slide that I showed you previously of that technology stack, you would have seen data analytics, and that was number one on the list. It is absolutely clear that if you had to pick one thing to work on, it is digitization and data analytics. The maturity level is there today. The commoditization of the ability to get compute, memory, and storage power is there today. Data analytics is really the next thing that we can tackle as an industry. So if we look at data analytics in this particular vein, so if we're really trying to get at real-time data analytics with process control, it's unfortunately not very widely implemented. Again, there are always pockets. It's done very well, in some areas, but again, taking this broad view of the industry, there's a lot of opportunity here. So I mentioned the semiconductor industry before, highly sophisticated. Again, they need to be to get the product out the door. In the manufacturing sector, just before COVID, I was still doing quite a bit of travel. So this would date up into the beginning of last year, 2020. Many facilities are still very, very manual. Data collection is messy. There's too much data and they don't know what to do with it. There's IT/OT integration barriers, difficulty, security requirements. And what this really means is that it leads to this reactive batch style data analysis, which we're trying to break away from, which we still can't quite do in all cases. But what we want to do is we want to turn that pivot to a proactive real-time continuous data analysis. That is enabled by the systems for data to flow. So if we're going to have this actually happen, if we're really going to have a chance at this, again, from an industry perspective, we need to be thinking about data formats, data flows, collection, and then the contextualization and analysis. You can think of this as plumbing. You can think of this as infrastructure. If we don't have this in place, then a lot of the claims or the promises of what we're trying to do simply will not be realized. And again, that return on investment will not be there. So there's a lot of different product level driving forces. You can see, quality, reliability, maverick lots, throughput, efficiencies. All of these are very common things we chase today. We need to really be careful and clear on an overall data structure, not just for our own facility, our own company, but also for our supply chain and our partners who we're interacting with. How can we start? This is obviously a big problem, but think about your data formats. Think about your communication protocols. Think about mapping your process in the terms of data. Applying SPC. These are all things we can do today. The tools exist. They're very well utilized today. And the goal would be to get that real-time health of line continuous monitoring so we can flow with the data. So with that, let's talk about data analytics a little bit more. So when you turn on your computer and we see all this information coming at us, this is what you see, right? We see really interesting graphs through the press and through consulting reports. And we say, well, if we just had this at our fingertips, we'd be much faster, more nimble, and more profitable. However, when I look at data analytics, and this comes from my master black belt engineering days, this is what I see. Hopefully, this is what many of you see. Is data populations of whatever you're building, upper lower control limits, keeping things in control. This is just one example. This is keeping an eye on making sure that what you're building has a quality level to it. And if we're really going to get there, again, linking in Factory of the Future, which I talked about, linking in data analytics, how do we actually create that pipe and create that stream of data that is coming from our lines all lines, every line, all the time, securely, and real time. And so when you add all this up, it goes back to my big data slide. I mean, you get into a lot of data very, very quickly. What data do you want? What data do you not care about? There's a lot of decisions. Just because you collect data doesn't mean it's useful. And I would argue that as we start to get into some more advanced topics like multi-process AI learning models, time series performance, all these things, we really need to take a step back and think about where the data is coming from. And that is what CFX is able to do. This is basically a common open source machine data protocol that allows data to flow, not just be upwards into the IT/OT network for data analytics, but also allows different pieces of equipment to talk to each other during processing. So the main point that I want to bring out on this slide is that if we're really going to get to data analytics in the way that we all wish and hope and want, we need to be thinking about some of the fundamental infrastructure to get there. Here's another look at CFX in terms of how it can communicate. So on the bottom, it represents an M1, M2, M3 equipment set. You can basically look between equipment, which is great. You can adjust equipment if you need to. But I think most importantly, we're actually now able to talk flexibly into a variety of things, either MES systems, routing brokers, direct networking, for a whole variety of things that you might want to do in your facility. And you can see that very long list of things that you may want to do. So to conclude, CFX, basically it's the advantage of it is that it's plug and play. You've got different pieces of equipment. We've got different legacy data exchanges. You don't need middleware or customization. This allows for scale as the solutions are built. And it's also a one-stop shop floor collection method. Again, everything just like, and again, thank you. We are all speaking English right now. If we were all speaking different languages, I wouldn't understand certain elements and others may not as well. So it unifies the data flow and the message sets. It's open source. It's all developed on GitHub. There's a lot of detail here, which I will not cover today, but again, is meant to be open source for continued development. The other thing that's really exciting about where the industry is with 2591 is that it's an active industry committee. Some of the other options out there, I will provide an example for SexGem. That was developed in the 1980s by Hewlett Packard and is not as dynamic and being modified today, for example. So we just released version 1.3 for the industry to use, and we expect 2 revisions each year as this develops. Just a couple of key points on this. We talked about security. This is all based on AMQP. This is the same data format protocol that international banking systems use. So all money is transferred through AMQP protocols. We're using the same trusted source. Messages are formatted in JSON. And again, just trying to make sure that we're using common platforms for the data structure. So what's interesting about CFX is that it's not a proprietary way of coding the image or the data, but we're actually using widely existing formats. What we've done is we've spent the time encoding messages that are very specific to the manufacturing process, which really makes this come to life. If you're interested more on implementation and adoption where we are today, you can go to the website shown on the screen. We have over 100 different global companies supporting this initiative right now, and definitely continuing to grow. It's a combination of equipment suppliers, manufacturing partners, software suppliers for data analytics. All of this needs to work and plug together. If you're interested in getting more involved with CFX, you can contact my colleague, Chris Jorgensen, at the email provided. You can also visit our IPC CFX website shown on the screen. So thank you for your time and attention today. Again, if you're interested in more about what we're doing here at IPC, we are absolutely focused on investment moving forward. As I mentioned, you can contact me at the email shown or give me a call. Thank you very much for your time, and we'd be happy to take any questions.
Thank you for your presentation. I think now it's clear that way the electronics industry is on, but unfortunately we have to keep running.